In this lesson, we will study magnetism. First, we start to know about magnets, their poles, forces, and laws. We will look at the magnetic fields generated by magnets. So let's begin with the definition of magnets. What is a magnet? A magnet is an object which attracts anything containing iron, cobalt, nickel, and some alloys of iron oxide. When these materials are called magnetic materials, all other materials are called as non-magnetic materials. There are two types of magnets in the universe: natural magnets and artificial magnets. Natural magnets which can be found in nature, and artificial magnets which are produced in various shapes for different purposes. Cylindrical, U-shape, ring, disc, and bar magnets are the most common type of artificial magnets. Every magnet has two poles. One is called North Pole and the other one is called South Pole. If you cut a bar magnet into half, each half will still have a North and South Pole. You cannot have a magnet with just one magnetic pole, and it's against the law of nature. Well, the other one is a magnetic force. Two magnets can attract or repel each other due to magnetic force. As you can see on the picture, when unlike poles attract each other, similar poles repel each other. A magnetic force is strongest at the poles of magnet, but it's not limited to the poles. Magnetic forces are exerted all around the magnet. The area of magnetic force around the magnet is known as its magnetic field. Because of magnetic fields, magnets can interact without even touching. Magnetic field lines around the magnet are invisible. They spread out from one pole, make a curve, and return to the other pole. They never cross each other. The magnetic field of Earth, the Earth is a giant magnet itself. The geographical pole and magnetic pole are not at the same place. A compass is a device which indicates the direction, and it usually points the north. What is a magnetosphere? The Earth's magnetic field exerts outside the atmosphere. The region of Earth's magnetic field is called the magnetosphere. I would like to talk about northern lights, also known as aurora borealis, and it's a natural light display in the Earth's sky, usually seen in the high latitude regions around Arctic and Antarctic. It's the result of disturbances in the magnetosphere caused by solar wind. The particles, mainly electrons and protons, accelerate into upper atmosphere. I want to finish this part with a short video which explains the creation of northern lights on our planet. Enjoy it.
On Arctic nights, the aurora often flames across the winter sky. What is it, and where does it come from? This is where the tale of the aurora starts. On the Sun, a star of average size among billions of other stars in our Milky Way. The Sun acts as an enormous power plant. The energy is created deep inside the core of the Sun. Here the temperature is over 14 million degrees, and the pressure so enormous that hydrogen atoms are squeezed together into another element, helium. This nuclear reaction releases energy. The light radiates outward from the core of the Sun. In the outer layers, the heat moves to the surface in huge eddies called convection cells. These electrical currents of charged gas create magnetic fields inside the Sun. In some places, strong magnetic fields push their way up through the surface. They slow down the eddies of hot gas. The surface cools, and darker sunspots appear. The electrically charged gas is called plasma. The plasma drags the magnetic field further outwards. The magnetic field stretches and twists like a rubber band, and and then the rubber band breaks. Several billion tons of plasma is hurled out from the sun. This is called a solar storm. The solar storm can reach speeds over 8 million kilometers an hour. After 6 hours, it blows past the planet Mercury. After 12 hours, the planet Venus. And after 18 hours, the solar storm reaches Earth. When the solar storm reaches our planet, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm. The magnetic fields couple together and create a funnel where the gas streams down on the daylight side of the pole. This is the daylight aurora. The magnetic fields stretch further back and couple together. The magnetic rubber band breaks, and gas from the solar storm streams along the magnetic lines towards the poles on the night side. This is the nighttime aurora.